Okay, thank you very much. I'm really happy to be here. Um, I've enjoyed the morning very much. I didn't get here till yesterday because I was teaching yesterday morning. But I'm been asked to speak about what we can learn from long-term crop rotation studies. And I was really thrilled to get the invitation because you want to hear about this and I want to talk about it. So that's fantastic. I'm here in southern Alberta. I've got a picture of Medicine Hat because one of my graduate students, Calvin Dick, is from Medicine Hat. And that drill that we use at the Glenley rotation is a Noble drill. When I bought it for the rotation, Guy Lafon said, "Why are you buying that drill for your clay soil?" But it's what I bought. And up on the left, I wanted to acknowledge all of the wonderful long-term crop rotation studies that have been that exist. Everywhere, and including Alberta, and I'm going to highlight some of them. So when we think about just a few introductory remarks about long-term studies, because they're always useful. The oldest in sort of the modern era is just north of London, England, at Rothamsted, and it was started in 1843 by Gilbert and Lawes. Lawes was a fertilizer manufacturer and very interested in the long-term effects of fertilizer, so set up this experiment, and we've learned an awful lot from that study. In Alberta here we have the, we've got the 1910 plots at Lethbridge, but I want to talk about the University of Alberta Breton plots, which are in grey wooded soil, and they were started in 1930, and already early on, as you can see from the picture, I'm going to see if this works. Turn the laser pointer on. Yeah, even early on, we're learning about how some supposedly sustainable practices may need to be tweaked. For example, this is wheat after clover, and I love the way they measured this. This is a lot easier than doing statistical analysis and getting a Wintersteiger combine, which sometimes breaks down. But there you've got your untreated check, and you can see it's the smallest bundle. And so what was observed very early on is there were some other nutrients other than nitrogen limiting this wheat after clover. Here's another wonderful research method from Breton. This is much easier than doing all kinds of analysis on the grain. Just feed it to 4 rats, give half of them the crop from the lousy plot and half of them the crop from the good plot, and you get your answer. And we've done some of this work at Glenley, but it's been way more complicated. Clearly they observed that soil quality was important to the health of creatures. At the University of Manitoba, we had some long-term plots. They were located where the Winnipeg Blue Bombers are trying to win these days. And actually, Gilbert and Lawes from Rothamsted came to Manitoba and collected soils. And we know about all that because Henry Jansen from Agriculture Canada at Lethbridge has documented that history very nicely. And what we learned really from these University of Manitoba long-term plots are things that we really already knew from Rothamsted. And that is that manure application was really important for a sustainable system if you don't have fertilizers. So yeah, that really interesting history. And then if we move forward to the last 50 years, 30 years, we've had a tremendous interest in no-till. As you know, how many of you are no-till farmers? Put up your hands. Okay, so almost none of you. We've had a great team. We heard a great example from Neil this morning of the quality of work that Agriculture Canada has been doing. So we've been very interested in no-till and soil biology, right? That's the newest of the soil sciences is soil biology. And there's been a tremendous amount of work from mostly Agriculture and Agri-Food Canada scientists on this. And I want to put a plug in here for when you talk to your members of parliament, tell them not to cut all the programs, please, because universities and provincial governments don't do a great job on these long-term studies like the federal government does, because they've got the long-term interest, and it really does make a difference. It makes a difference to practical farming. Okay, so turning to the subject that I was asked to speak on, organic. Why organic farming? Well, there's a number of reasons. There's economics, there's exploring new markets. We have a program right now where we're trying to get farmers to convert just a portion of their land to organic and set that up as a separate business unit, because we want those excellent management skills from the current farm population into organics. We need those management skills. There are environmental benefits, and some farmers like the independence. Some farmers like the challenge. I met with a group of farmers here from the region yesterday, and we had a wonderful talk for 2 hours. These farmers were really interested in just trying new things. They were very intelligent people making a difference. And why organic research? Well, we can learn new things, and when you take those inputs away, you learn a lot of things. It's very helpful. And also, necessity is the mother of invention, and when we make a necessity for ourselves, as researchers, sometimes we come up with things that are useful. The first organic research farm in Canada is, you can't miss it. When you drove by Davidson, Saskatchewan, there was a sign there. And that's gone now. That farmer has retired but did a whole career there. So I wanted to acknowledge on-farm research. But if we look around the world, there are quite a few long-term studies looking at organic and conventional production. I have visited or worked on most of them. All the European ones, the Australian ones, the Canadian ones, and one of the American ones. So there's been a lot of really interesting knowledge come out of them. The oldest of the long-term organic conventional comparison studies exists in Switzerland, near Basel, and it was started in 1978 by farmers. The farmers went to the government and said, we want to work in partnership with you and set this up because we think it's important. And that's Paul Mader. Paul Mader has published in all the best journals on their work, and he's a soil microbiologist and has learned many things, and we've had the chance to work with that group quite a bit. They're really good scientists, and they've taught us a lot. The first time I went to the DOC trial, it's called, in Basel, Paul said, just take a look at the soil, go into the plots and look at the soil. And they're in a till-based agriculture. But I swept the wheat aside and looked into the we've all done that, right? Looking for our glasses or our crescent wrench or whatever. And, and there on the conventional side, you can see the soil was, typical soil. On the organic plots, we saw all these earthworm casts. And so, that was interesting. Picture tells us 1,000 words. So I'm not going to talk anymore. Just get you to look at least for this picture. The DOC trial they published a paper in Science in 2002, and they actually concluded that organically managed soils are more energy efficient soils. This is what they measured. and this is being measured in Canada by Newton and other microbiologists as well. They measure the amount of carbon that it takes to keep the microbial biomass alive. It's an efficiency measure, very, very simple. And what we're finding is ecological farming systems, whether they'd be no-till with good rotations or organic systems with good rotations and good nutrient programs, it takes less carbon to get your per unit of living carbon in the soil. You get more life in the soil per unit of carbon. That's called energy efficient soil. So the DOC trial has got us thinking about carbon fertilization. Okay, so that's a term that they like to use, and I think it's important. Okay, coming to our study, we started the Glenlee study. I started the Glenlee study in 1992, and my former department head, the late Ian Morrison, who some of you may know, he's an Albertan from Lacombe. He's the only one that supported me. The old timers in the faculty were like, you can't do this, we're not giving you the land. And Ian said, well, it's not really research, Martin, but go for it, He caught the vision, he saw the value in it. And so I really want to just make you pay attention now. We've got two farming systems. One is with alfalfa and grains. Okay, that's number one. The second is grain only. Okay, so we got those two rotations or farming systems, and then we have those under conventional and organic at Glenlee. So that's really what we're comparing. It's a replicated study. It's got a prairie in it. I named one of the prairies the Grant McEwen Prairie. Grant McEwen used to be the dean of our faculty, was also the mayor of Calgary, and an ardent conservationist, and I have his books in our Clubhouse Learning Center at the thing to get the grad students to read. But for the first 12 years of the study, I didn't just have organic and conventional. What we did is we split the had the very, very large plots. It's before we created the small plots, which you see here. But so we had like half the plots received no fertilizer, half the plot did, and then we split them this way, where half the plot received no pesticides and the other half did. So we could really look at the effects of other input factors. And I'll just show you some of those results because they're quite interesting. This is flax in the 12th year of the study. Here we have the grain-only rotation. Here we have the forage grain. They're 4-year rotations. This has 2 years of alfalfa and wheat and flax, and this has soybean, wheat, oats, and flax. And what's interesting here is here we have the no fertilizer plus herbicide. We haven't added fertilizer for 12 years. Look at this rotation here where we've had alfalfa. It's doing really well. What we learned in the first 12 years is that herbicides were way more important than fertilizers. That was quite interesting. But then the fertility started to diminish. The other just thing off the first 12 years I want to share with you is the effect of fertilizer on weeds. This is the plot of oats here. This was in the 12th year when we had split the plots into these 4 meter by 30 meter. And here we have added pesticides, which means herbicides mainly, and no fertilizer. So you can take a look at that. And then where we add the fertilizer, you can see what it's doing to the weeds. And so, you know, this is really showing us that the fertilizer is definitely driving weed communities. And then the final slide on this first 12-year phase just looks at the grain-only flax versus the forage-only flax, and it emphasizes how important, these are both organic sections, and it shows how important crop rotation is to make organic farming successful. In this grain-only rotation, where we have the green manure only 1 year and 4, the flax crop is not very good. We do have some wild oats. Here we have an organic flax crop following alfalfa, and it's a very nice crop. The other thing that you will notice is that on your right, the crop is a bit smaller than on your left. Those crops were seeded about 1 week apart, and that's early seeding. That's later seeding. So the point I want to make here is the combination of rotation and management makes a big difference. Okay, so since 2005, we started running into some nutrient challenges, and we transformed the rotation in a number of ways. All the basic rotations still stayed there, but and we also have this playground here. If anybody wants to come play, come with your ideas, and we'll try to implement them. And this is the Clubhouse Learning Center, which is built out of recycled lumber from one of the urban developments near the university. I stole lumber for a whole year, and they liked it when I took they were sending it to the landfill. So I got a bunch of high school students to build that, and that's where Grant McEwen's library is, where books are. So here's the wheat yields from early 1990s, whatever, to the present, and you can see that those are the conventional yields in light blue. The dark blue are the different organic yields, and you can see we did basically, the point I'm trying to make here is it took us time to become good organic farmers. And now we have some organic yields which are similar to, or not so much lower than conventional yields, but it has taken us a while. Let me try to illustrate that with pictures. Here's some photos I took this summer. Which is the organic plot? The one on the top left or bottom right? It's really kind of hard to tell. These are in the grain-only rotation, and the plot on the top left is the organic wheat, and the one on the bottom right is the conventional wheat. Same variety, planted on the same day, and the organic wheat in the grain-only rotation follows a green manure year. So that we would expect that wheat crop to be quite good. If we look at the yields from 2014, not a real stellar year. We had huge rains in June, which really hurt the crops, and then we had very dry conditions later in the year. So it was just one of those normal years. So let me show you the rotations here. We've got the annual rotation is flax, oat, soybean, wheat. So we're looking at the wheat yields following soybean. When we grow those things organically, instead of growing the soybean, we grow a green manure crop. So conventional 33.7 bushels per acre last year. Organically, with no compost added, 29.4. Not unusual because we're growing the wheat in the most favored time in the rotation, right after the green manure plow down, quote unquote. And then where we add compost manure, 5 pounds of actual phosphate per rotation, that means for every 4 years, it really doesn't make a difference to the, to the wheat yield, because the annual rotation, even after 23 years, this is 23 years into the rotation, we're still not really seeing any phosphorus deficiency in these systems. That is very different when we look, and maybe your eyes have already gone down to the rotation that contains alfalfa. It's a flax, alfalfa, alfalfa, wheat rotation. The alfalfa is harvested for hay 2 times, maybe 3 times during the growing season. Under conventional management, 34.1 bushels per acre, not a great wheat crop, but that's what we harvested this year. When we do that organically, you can see where we didn't add compost, look at that, 12.6 bushels. Not a really great crop. Why is that happening? Well, you've already figured it out. It's because it's short of nutrients. In fact, it's short of phosphorus. When we correct that deficiency with some compost, here we're adding 40 pounds of phosphorus, not P2O5, but phosphorus per rotation cycle, and that's composted beef or dairy cattle manure coming from organic operations. We pretty well correct that deficiency. So this has given us a lot of important lessons in long-term management of these rotations. Let me move on to the flax phase. This is another crop that appears in both rotations. Which is the organic? The one on the, this is now flax in the flax alfalfa wheat rotation, taken in 2014, which means it's the 23rd organic crop on these plots. The organic plot is, now I have to think here, it's it's the one on the bottom right. And you can see it doesn't look quite as good as the one on the top left. If we look at the flax in the annual grain rotation, flax, oat, green manure, wheat, which one here looks like, which one do you think is the organic one? Top left? How many of you think top left? Okay, you're right. That's the top left. Doesn't look quite as punchy as the conventional one here. But it doesn't have a lot of wild oats in it. It has a few wild oats, but not too many. The alfalfa, as Neil pointed out, does a pretty good job of controlling the wild oats. It's only a 2-year alfalfa stand. It's too short. It should really be 3 or 4 years, but that's how we started off the study. And here's another replicate of the study. Which one is the organic plot here? It's again the one on the top left. The bottom right, we have herbicide-resistant wild oats. And this year we're starting to use trifluralin in those flax crops because we can't control our wild oats anymore. In fact, the soybeans in this rotation are Roundup-ready soybeans, and they're really important in the conventional side to control the weeds. So this was a bit of a surprise for us, and we got hit in one of our replicates with herbicide tolerant. What about the alfalfa? How's the alfalfa growing in the organic and conventional systems? Which one here is the organic? It's hard to tell. The one on the bottom right is the organic, and what if you use your imagination, you'll see the front half of this plot looks better than the back half. Let me show you another replicate of that exact same thing. Where we haven't added the manure, which we always add as compost, we sometimes have very, very poor alfalfa yields. Why is this? Well, it's low available phosphorus. And so what's happened in the organic system that has the alfalfa hay in it, we're exporting that hay, exporting the phosphorus, where we're not bringing the phosphorus back in terms of manure, composted manure. We're reducing the alfalfa productivity. That means our nitrogen factory is slowing down, and that's translating into poor wheat crops. So we've learned an awful lot. Now, there's a lot of things to learn about phosphorus. This is the spores that form the mycorrhiza. There's a lot more of them in the organic soils. I don't really have time to talk about this, but we see a lot more organic phosphorus in the organic plots. We also see, this is an interesting study that one of my graduate students did, looking at, this is really living carbon, okay? This is living carbon in the top 15 centimeters or the top 6 inches of the soil. And what we see is going from conventional to organic, whether we add compost or not, actually provides a significant increase to the living carbon in the forage grain rotation. Right? But in the grain-only rotation, we actually see the opposite effect. Going organic causes a statistically significant decline in the living carbon. The problem is this rotation is just not putting enough carbon in. So this one is carbon fertilizing to an acceptable level. So many things that are interesting to learn here. Now, I wanted to just pause and show you some of Alan Franzluber's work. Alan actually did a postdoc with Ag Canada in northern Alberta with Charlie Arshad years ago. He's a soil sequestration specialist, and he works in Georgia now with USDA, and he's asking himself, how do we build carbon in soils? And he was looking at years of short-term pastures. And when you grow Bermuda grass and cut it for hay, it did not increase the soil carbon. When you left that Bermuda grass just unharvested, still only a small increase in carbon. But look what happened when that Bermuda grass was grazed. You actually got increases in carbon in the surface soil. This is the kind of stuff that Alan Savory talks about. There's a lot of information like this in the scientific literature that grazing does help our soils accumulate carbon. And so now that we know that, one of the things that we're doing at Glenlee is we're starting to not hay our forage phases, but we're starting to graze them. So we have a little flock of sheep here, and I think I'm the only agronomist in Canada that has a flock of sheep. So I'm very proud of that. The other benefits to this is economics and nutrient recycling, which I'll talk about in a minute. The other challenge with Glenlee is where we are not adding alfalfa to the rotation, we're losing subsoil carbon in the organic systems. That's a big alarm bell. We've published that work in 2012. We went right down to 4 feet. But when we look at the prairie had very deep roots, roots down to 7 meters. And that really helped us build our soil. So, you know, alfalfa is one plant that can go that deep and provide those benefits. Now, we also conducted a second long-term study because at Glenlee we had some constraints, because when you're in a long-term study, you know, there's certain things you can't change because you started that way. And so what we did is set up a 6-year rotation using all that we had learned. So it's we did it at our Carmen Center, and we made the plots 2 acres each. Green manure, we grazed the green manure. Then we went to spring wheat, then soybean, then a green manure of hairy vetch barley, which we rolled, and then we had 2 no-till crops, flax and then oats, and we no-tilled into the vetch. When the crop would be weedy after the flax, we chose to no-till rye instead of oats because it's a more competitive crop. So the crop yields are very good here, but this is good management. One thing that we've learned is a green manure 1 year and 4 is not often enough. 1 year and 3 is a minimum. And then you can make lots of nitrogen. These are our yields, and yes, we're in the black soil zone, and these are our long-term 7-year average organic yields. You can go to our website and get this information. This is we had an economist do the economic analysis, and the net returns were actually, where is my mouse here? It's disappeared. There it is. Our net returns were no higher with organic than conventional, but the costs were lower and the returns were comparable. And we also did this work during the period right here when organic prices were really quite low. But anyways, that proved to us that when we use a better rotation, we can grow better organic crops, and we can actually introduce some very limited no-till into the organic system. So I want to finish off with 2 points. The first is about green manure choices, and I do want to say a little bit about the organic no-till. And after hearing Neil's talk, which there was a lot of news in there for me, I think it's important we talk about alternative ways to suppress weeds in no-till systems. So in terms of green manure crops, it's my experience that this question always comes up with farmers. What's the best green manure crop to grow? Well, there's so many species. There's a species for every soil type and soil setting. For example, chickling vetch for dry areas, faba beans for wet areas. There's combinations that are quite widely adapted, 40-10 forage peas of any kind, and oats, for example, very, very popular, high production, lots of nitrogen. And then there's hairy vetch, which is one of the better nitrogen fixers. We're just learning how to use it. We're just learning, we don't even always know what variety is that we're buying, and there are real big differences in the winter hardiness of the varieties, so there's lots to do. But we have a large hairy vetch program at the U of M. It's very widely adapted, and it's got all kinds of potential. There's legumes for hot, dry conditions. If you're not seeding your cover crop until June, you can use some of the tropical legumes. And then there's the idea of growing combinations of crops. And this is what we've grown a lot of at Glenlee, a mixture of pea, soy, faba bean, and oat. Pea does well when it's dry. Faba bean and soy do a lot better when it's wet, and faba bean does very well if it's wet and cool, at least relative to peas. And what we've been promoting with the farmers is this idea of growing a green manure every third year. But the farmers say, look, land prices are going up. I can't afford this. So my point was that we've really been talking to farmers about grazing the green manures. I've had a number of grad students looking at grazing green manures and what that does for the nutrient cycling. And our economists tell us a grazed green manure in our Carmen study moved our net return for the green manure from minus $66 an acre to plus $30 an acre, and that's including the temporary fencing and the watering. So I'm really happy with this experience here. This is Ian Grossert's organic farm south of Brandon, Manitoba, and this year for the first time he started grazing his green manures. That's a combination of peas, oats, and hairy vetch, and I think that makes a lot of sense. And when we look at what's happening with the human nutritional consequences of how we feed our animals, this is a little dangerous mentioning this we're close to Feedlot Alley, but we know that feeding animals, finishing them on forages makes healthier meat, healthier milk. This year in Winnipeg, you could buy pasture butter that came from dairy animals that were only on pasture. It got a premium. Just a few other one other green manure point here. This is organic potatoes after alfalfa, organic potatoes after buckwheat. Buckwheat is a non-nitrogen fixing crop, but sometimes these non-nitrogen fixers do other things in the rotation that help that potato grow well. There it is after peas, and there it is after sorghum Sudan. So sorghum Sudan didn't work that well on its own, but buckwheat did. So it's more than nitrogen. Okay, just to wrap up, I know we're almost out of time, and I'm occupying the space between now and lunch, so I recognize that. Organic no-till, is this possible? The short answer is, if you do it right, it'll let you no-till for 1 or 2 years based on our experience. So the bits of equipment that we use are the blade roller and some kind of a no-till drill. This is an offset no-till disc drill, a little toy, and the right species. So hairy vetch has been a very important plant for us in this organic no-till idea because of its indeterminate growth habit. What we do here is grow a little bit of barley with hairy vetch. When the barley flowers, we blade roll it with this thing. This crimps everything, leaves it. Anybody who's worked with a stripper header and seeded into anchored plant stubble knows that you can seed into lots of residue if it's anchored, much better than if it's loose. And this will also kill the wild oats that are growing in there, or the foxtail or other grasses. And then the hairy vetch, being indeterminate, will start really taking over. It doesn't do anything. It's like a second half team, right? Football team. Don't expect anything out of your hairy vetch in the first half. The barley is out of the blocks, and the hairy vetch finishes off the game. And it grows well into freeze up. And we did some plots at Lethbridge where the hairy vetch did not winter kill. The variety selection is critical. And then we create this mat here. You can see that mat of hairy vetch. We're direct seeding right into there. And if you go to our website, which I'll show you later, you get a video of this seeding operation. In terms of the, I have to thank my technician, Keith Bamford, who invented this system, and also many grad students who worked on it. This is the mulch of hairy vetch barley when we're seeding into it. What we do know is you need at least 6 tons per hectare of mulch biomass in spring to suppress weeds. That's a number that's been used all over the temperate world now. If you're in the black soil zone, you can produce 13 tons per hectare of hairy vetch barley. And what I like about it is you're putting this mulch down. You'll notice that the barley carcasses are against the soil. That's because we blade rolled it and we laid them down, and then the hairy vetch grew above them. This is genius. So you put the high carbon plant material against the soil, so the hairy vetch isn't against the soil, so it doesn't decompose so quickly. That's all the things that Carolyn Auld, who's a PhD student with me, discovered, and we've worked on this for quite a while. There's flax no-till seeded into hairy vetch. There you can see it coming out through the mulch. And there's the next picture is our first organic no-till wheat crop in 2008, seeded into the barley hairy vetch. And there's the mulch suppressing the weeds, almost done. And here's some of Carolyn's work. She looked at barley mulch by itself and then barley hairy vetch mulch. This was a year that we couldn't actually plant the wheat until almost June because it was so wet. And what was really impressive is that hairy vetch mulch suppressed those weeds, and we grew the wheat crop, and there's still no weeds punching through. So this is in its infancy. Blade rollers are, there need to be designs for dry areas. Maybe we need to integrate some noble blades into this system. We're doing that now. But organic no-till is something that has some potential. Okay, so I'm going to wrap up there, and thank you for your attention. Again, thanks for the invitation. And if you Google those 3 words, natural systems agriculture, you'll get our website, which we promise to update this winter. And I'll turn it back to Andy. Thanks so much.
Are there any questions? He's over, but this is interesting. If there are no questions, there's one right there. There's 2.
Any idea how late the vetch can be seeded and still seed out response?
Okay, the question was how late can you seed the vetch and still get the response? You can seed the vetch quite late, like well into June, and still get a lot of biomass production. The thing about that mulch, if you seed the vetch too late, then it kind of acts like winter wheat and it overwinters like a winter annual. But seeding it any time in June, we've never had that stuff overwinter. So I would say any time in June. I have a little farm and we seeded ours at the end of June, and it produced a lot of biomass. It's very much a second season crop. It's a cool season legume, so it loves the autumn period. But the earlier you can seed it, the more biomass.
Very interesting presentation. Just a quick question regarding the fertility. You made a comment that you had noticed that there was a depletion of nutrients at one point. When you guys were measuring the spectrum, was it just the macros or the micros as well? And when you brought that around to increase the levels of fertility, did that include the micros as well?
Okay, that picture that I showed of the rats, that paper actually has, we did micronutrient analysis on Glenlee, and what we normally see, even on the phosphorus deficient soils, is the micronutrient concentration in the grains in organics is almost always higher. Almost always higher under organic, and the literature would support that as well. And that's probably because there's more mycorrhizal activity, and the mycorrhiza are picking up the zinc and the iron. And the other thing, I'm going to throw this in, since you said it was interesting. When people say, is organic food healthier, a lot of people say, well, the micronutrients, we can get them other ways. There's also, we have all the grain archived. We'd like to look at phenolics and other secondary plant metabolites, which are really useful for people, because the literature, they're often higher under organics as well, and it's a plant stress response.
Okay, thank you.
Okay. Thanks, Randy.